In section 3.5, we're going to look at yet another way to graph, and we're going to be graphing using slope-intercept form. So we're going to want to work with graphing using slope-intercept form and also be able to identify parallel lines in this section. And your vocabulary is going to be slope-intercept form and parallel. What does parallel mean? So if you want to look at finding the slope and the intercept of a line, slope-intercept form is defined as an equation in the form y is equal to mx plus b. So you might think of this as an equation that's been solved, a linear equation that has been solved for y. Okay, so y equals mx plus b. And one of the advantages we have is that we know that the slope will be the coefficient with x, that's the m, and the y-intercept will be the b. That's why it's called slope-intercept form, is because it shows you the slope and the intercept. So if we take a look at this particular equation, my slope is 1/3 and my y-intercept is 1. So if I start here on my y-intercept of 1 and I follow my slope, I go up 1 and right 3. Remember, slope is rise over run. So I'm going to move vertically 1 because that's the rise, and then 3 to the right, that's the run. That makes 1/3. And that will give me a second point and allow me to graph. Previously, we've used an input-output table to create 2 points, and we've used the intercepts, the x and the y-intercept, to create 2 points. So if we take a look at just identifying slope and the y-intercept, my slope in this case is -1/4 right there, and my y-intercept is going to be 8. Okay, so that's just practicing identifying these items, but let's look at graphing. So in this case, I'm going to go ahead and put in my axes here. Okay, and that guy's just a little bit off, so let me move him where he goes. Okay, right there. And I have a y-intercept that is 2. So 1, 2, there's the y-intercept. And the slope, that is -5/2. So now what's interesting with negative slopes, remember -5/2 is equal to rise over run. That means that I can apply the negative part to either portion of this. So one of them would be positive and one of them would be negative. So if I apply it to the rise, I'll go down 5, 1, 2, 3, 4, 5, and then +2, right 2, and there's the second point for my line. But I could just as well decide to make the rise positive and the run negative and go up 5, 1, 2, 3, 4, 5, and left 2, which would be -2. And you'll notice it doesn't make any difference which I do. I'm still on the same line. Okay, so when we're working with the notion of following the slope from the y-intercept to the next point, we have different options in terms of how exactly we go about that. Okay, so just remember, equally, if I had a positive slope, I could go up and to the right, but I could also do negative over negative, and I could go down and to the left, and that also makes positive. So what you want to do is do whatever you feel is simplest and easiest for you. In this problem, we're looking at different ways to get from floor to floor in a library. I can either take the stairs or the escalator. I climb the stairs at a rate of 1.75 feet per second, and the escalator at a rate of 2 feet per second. So I go up the escalator a little faster. I have to travel a vertical distance of 28 feet, so that doesn't change. And they've created 2 different equations for me that I could work with for this, one for the stairs. So you'll see that my distance is going to be equal to -1.75 t plus the 28. So this is the distance I have left to travel. after t seconds. So obviously when this reaches 0, I'm on the next floor. And for the escalators, it's d is equal to negative 2t plus 28. So let's take a look at graphing these. And if I go ahead and put in my axes again, now I'm going to go ahead and actually I'm going to move this over because I know that I'm not going to be moving negative time, right? So I can stay here pretty much, nor will I be traveling a negative distance. So in this case, if we take a look at going ahead and graphing this, so for my line, for line 1, my slope is negative 1.75, right, which could be, let's see, 4 quarters and 3/4, that's negative 7 quarters. I find that a little easier to work with slope. And my y-intercept is 28. And for the second line, my slope is negative 2. My slope is equal to negative 2, and my y-intercept is also equal to 28. Okay, so when we start from the ground level, we have 28 feet still to go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 14. So if I do this by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. This is 28, and that's the y-intercept for each of my lines, line 1 and line 2. So if we look at my slope of my first line, again, I can go down 7 and right 4, or I can go up 7 and left 4, but you can see, especially the way my graph is working here, that doesn't make any sense. I'm going to want to go down 7 and right 4. Now, I did my graph in 2s here, but it doesn't matter how many 7s I go down as long as I'm consistent, right? So as long as I keep my graph consistent on my scale, then it's okay if I go 7 2s and write 4 2s. So if I go 1, 2, 3, 4, 5, 6, 7, and then over 1, 2, 3, 4, that's a good second point for this particular line. And if we take a look at the other line, my slope is negative 2, so it's a little different. I'm going to go down to right 1. I can go down to right 1 and down to right 1. It's a little bit different. Okay, not a lot different, but it's a little bit different. Okay, and I'm going to start there and go this way. And what you can see is it looks like what happens is we finish out about 2 seconds different from each other, according to my graph. So that's the time that I save by taking the escalator, right? The difference here, this is time, 2, 4, 6, 8, 10, 12, 14. It takes 14 seconds to use the escalator, and it takes 16 seconds, right? This is 16, 0, and this is 14, 0. So I saved 2 seconds by taking the escalator. Okay, and at any given moment, this space between the lines represents the difference in how much time it has taken me to travel a certain distance. Using another problem where we're going to work more with the intercepts of the lines, I'm given two scenarios for producing commercials. A company produces two 30-second commercials, one for $300,000 and one for $400,000. And in each case, the airing of the commercial on each particular station costs $150,000. And if we start looking at the equations they've created for me, I've got the cost is equal to 150 times n. That's the cost per airing of commercial, plus the $300,000, which was what it cost to make it. Okay? And if we look at the other equation, it's 150 times n. Again, the cost for airing didn't change, but the second one cost $400,000 to make, so it's got the $400,000 being added in. If I want to graph the equations on a coordinate plane, again, we're going to be working within the first quadrant, so I'm going to stay there pretty much. And what I think I want to do is I'm going to want to go ahead and find my intercepts and then follow the slopes. So what we might want to do is go by, I'm going to think of my scale here in terms of hundreds. So if I take if I go by 25s, 1, 2, 3, 4, 1, 2, 3, 4, that's 100. 1, 2, 3, 4, that's 200. And 1, 2, 3, 4, that's 300. And that's where one of my intercepts is, right there. And 1, 2, 3, 4, that's 400, and that's where my other intercept is. Okay, and then we're going to have this slope that's going to cover the total cost once we add in for airing the commercials. So if we do this maybe 10, 20, well, that's probably, it's not going to get me to 150 very well, is it? My slope is 150. So that's going to be a little difficult. So maybe going by tens isn't going to work very well. Maybe again, if we go by hundreds, 1, 2, 3, 4, that's 100. 1, 2, 3, 4, that's 200. 1, 2, 3, 4, that's 300. There's a nice balance to that in terms of the scales being the same. So if I go 150, oh, no, my mistake. I'm laying this all out wrong. This scale is the number of times it airs. So we're really looking at 1, 2, 3, 4. Let's call that 1. 1, 2, 3, 4. That's 2. 1, 2, 3, 4. That's 3. So if we look at what does it cost? So from the 300, when I air it one time, it costs 150. Okay, that's what that looks like. And the same with the 400. If I air it one time, it costs me, that's 50, there's 100, there's 150. And in this case, you can see that these lines are essentially parallel lines, and they always maintain the same distance between the costs, and that's the difference in the cost of having made the commercial in the first place. And what it's important to note about these things is that what happens is when you have two different lines that have the same slope but different y-intercepts, those are parallel lines. If they have the same slope and the same y-intercept, they're actually the exact same line. But the difference of the cost is always in this case, it's always $100,000 because it doesn't matter. It costs me the same amount to air each commercial the same number of times. The difference is always going to be the difference in the y-intercept, the cost I incurred before I started airing the commercial. So to, again, take a look at that in terms of parallel lines, if we want to determine if two lines are parallel, what we would do is we would compare the slopes. So it's hard to tell sometimes from a graph how close are they to being the same. So let's just find the slopes. So if I look at the blue line, I'm going to find the difference in y, so 5 minus 0 over 0 minus -1. And that's 5 over 1, which is 5. If I want to take a look at the red line, I have 5 minus 0. That's the change in the y-intercept over 1 minus 0. And that's also equal to 5. Okay, so I know that these lines are parallel. But let's go ahead and let's take a look at the green line. And I'll have 6 minus 1 over 2 minus 1. And this one is also 5 over 1, so it's also 5. So these are all parallel lines. So if I'm confused and I'm not sure, sometimes maybe they're very close to the same, but they're eventually going to intersect. The geometric definition of parallel lines are two lines that never intersect. The algebraic definition is that they're lines that have the same slope. Okay, so that's what we have in this case. Three separate lines, they all have the same slope. They are all parallel to each other.